We want to solve quadratic functions by graphing and factoring. So the directions here say use factoring to find the roots to the given equation. So here we have f of x equals 2x squared minus 11x plus 12. And in this case, we can substitute in for the y value 0. And so we have the left side equal to 0. And now we can start to factor this right side of the equation. If we look at if there's any greatest common factors, we see that we have 2, 11, and 12, and there's nothing that we can reduce from there. So then we can start thinking about what it would take to factor this. So here we get our two binomials, and that's equal to 0. The only two numbers that are going to multiply to 2x squared are going to be 2x and x. So those are going to be stuck there. There's nothing that we can do to move those. And then the thing is, we got to think about what could multiply to 12, and here we have a lot of options. We have the 3 and 4. We have 3 times 4. We have 2 times 6. And we have 1 times 12. So we got to think about how do these numbers pair with 2 and 1, which we have already. Well, if we put a 6 here and a 2 here, 6 times 1 is 6, and 2 times 2 is 4. So 6 plus 4 is equal to 10. So that doesn't get us there. If we do it the other way, where we say 6 here and 2 here, we'll also end up with 10 because we end up with 12 minus 2. So that doesn't get us there either. So that one's out. If we do 12 times 2 is 24. That's not going to work. 12 times 1 is 12, and 2 times 2, that won't get us there, so that's not going to work. So we have to figure out where to put 3 and 4. 4 here would say 2 times 4 is 8, and 3 times 1 is 3. That will get us to negative 11, so that's going to be what we have 4 here, and we have 3 here. And they have to multiply, they have to add to negative 11 and multiply to a positive. So they both have to be negative. So that's in our factored form. And now we can use the zero product property to solve, to find out what our solutions are. So 2x minus 3 equals 0. And we can add 3. Then we get 2x equals 3, divide by 2, and then we get x equals 3 over 2. Next one we have x minus 4 equals 0, so we add 4, and we get x equals positive 4. So in this case, we have a multiplicity of 1 because each one of these x's represents one solution. And we look at 4x squared plus 28x plus 49. And we can see that there's not anything that we can factor out between those. And we also have one side of the equation is already equal to 0. So we can just start to solve this one, start to factor it. And what we get is, we can set up our binomials. 49, really the only thing that we could use is 1 and 49 or 7 and 7. And if we use 1 and 49, there's probably not a good way to get to 28. So I'm going to say that we're going to have to use 7 and 7. Couple options for 4. We could use 2 and 2, or 4 and 1. Well, 4 times 7 is 28, but then we have 7 times 1, so we're not going to be able to add to 28 if we use 4 and 1. So it has to be 2x and 2x. So 2x times 7 is 14, and 2x times 7 is 14. 14 plus 14 is 28. So these both have to be positive. And then one thing that we can tell here is that we have 2x plus 7 times 2x plus 7. And so we can rewrite that as 2x plus 7 squared, and that's equal to 0. So in this case, we're going to have a multiplicity of 2. And so we can say 2x plus 7 equals 0 by the zero product property. So we subtract 7. Then we have 2x equals negative 7 and divide by 2. And then we get x equals negative 7 over 2. And that is, we use the zero product property for that. And that is going to be a multiplicity of 2 because there are two solutions at the same point.